Today's topic is technical rate of substitution or TRS. This is a very easy topic and we will try to derive the technical rate of substitution by the production functions as well. So TRS or technical rate of substitution is today's topic. So let us take a production function at first. The production function is in the form as y is equal to function of x1 and x2. This is our production function. So we have taken a production function here, which is y is equal to function of x1 and x2. Now we will do the total derivative of this function. So the total derivative is equal to dy, that is the total derivative, that will be equal to del f by del x1 into dx1 plus del f by del x2 into dx2. So this is our total derivative. Now we know that if we are on the same indifference curve, then in the earlier portion of the economics we have actually derived the marginal rate of technical substitution or marginal rate of substitution. Now suppose this y dy, what is the value of dy? Dy is basically the output is constant and derivative of any constant is equal to 0, so dy has become 0. Now del f by del x1 into dx1 plus del f by del x2 into dx2. We will try to subtract this portion and try to take this portion in the left hand side. At first let us write all of this as it is. So 0 is equal to del f by del x1 into dx1 plus del f by del x2 into dx2. Now so if we take this portion, if we take this part on the right hand side, on the left hand side, then what will it become? It will become del f by del x1 into dx1 and it will be in the form of minus. Similarly, in the right hand side we will have del f by del x2 into dx2. Now if we take this dx1 and if we try to divide this dx1 with this dx2, then what will we get? We will get dx2 by dx1 and we have also del f by del x2 on the right hand side, and the left hand side has only remained with minus del f by del x1. So if we send this portion on the right hand side, on the left hand side basically, then what will we get? We will get this is basically, I have made a mistake here. This is del f by del x1. Now if we just want to send this portion or this part of the equation on the left hand side, then what will we get? We will get dx2 by dx1, that is on the right hand side, that will remain the same, dx2 by dx1, but the left hand side will now become minus del f by del x1 divided by del f by del x2. So this is now our left hand side. Now this is basically the marginal rate of technical substitution or technical rate of substitution. This is basically the technical rate of substitution. So what can we write? This is the technical rate of substitution. Now what is this portion called? This portion is called the marginal productivity of x1. This portion is called the marginal productivity of x2, and this is called the technical rate of substitution or TRS. So now what can we write in the place of TRS? Now TRS is basically, TRS or technical rate of substitution is basically minus del f by del x1 divided by del f by del x2. You can see it from the previous slide also. This is the TRS, minus del f by del x1 divided by minus del f by del x2. So TRS or technical rate of substitution is minus del f by del x1 divided by divided by del f by del x2. Now if a production function is given towards us, suppose a production function is given as function of x1 and x2, that is equal to x1 alpha, x1 to the power alpha into x2 to the power 1 minus alpha. We all know that this is basically a Cobb-Douglas production function. So for getting to the TRS, what is the formula of TRS? We have to derive the TRS from this production function. What is the formula of TRS? TRS is basically minus del f by del x1 divided by del f by del x2. Now, so we have to derive the value of del f by del x1, that is the partial derivative of the function with respect to x1. Now what will be the partial derivative of this function with respect to x1? This part will have a derivative and this part will not have any derivative. So what will be the derivative of x1 alpha with respect to alpha? With respect to x1, we will have alpha into x1 into alpha minus 1 into x2, this part will not have any derivative as I have said, so into x2 1 minus alpha. What will be the value of del f by del x2? This is the numerator part. We have derived the numerator part in this portion. We have to find out the denominator part now. What if del f by del x2? That is the partial derivative of this function with respect to x2. What will be the value? We will do the derivative of x2 or this part only, and x1 alpha will remain outside from the derivative. So x2 1 minus alpha, if we do the derivative with respect to x2, then 1 minus alpha will come before, then x2 to the power 1 minus alpha minus 1, because as per the formula, if we do the derivative of x to the power n, then what we actually get? N into x to the power n minus 1, that we basically get. So we have to subtract 1 minus 1 minus 1. So 1 and 1 will cut down, we will get 1 minus alpha into x2 minus alpha to the power minus alpha, that we will get. And obviously we also have the x1 as the constant part, so we have the x1 alpha that will remain in the equation. x1 alpha will remain. So what is the value? Let me do it a fresh value. So del f del x2 will now become 1 minus alpha into x2 to the power minus alpha into x1 alpha. Okay, so now basically what is x2 to the power minus alpha? Okay, so we have obtained both the values of del f del x1 and del f del x2. We have to put it in the equation, then we will get the value of TRS or technical data substitution. So what is TRS? TRS is minus del f by del x1. What was the value of del f by del x1? The value of del f by del x1 has been determined as alpha into x1 to the power alpha minus 1 into x2 to the power 1 minus alpha. So we will write the value. So TRS is nothing but minus alpha into x1 alpha minus 1 into x2 to the power 1 minus alpha. What is del f by del x2? That will be in the denominator part of the equation. That is 1 minus alpha into x2 to the power minus alpha into x1 to the power alpha. Now if we take this x2 to the power minus alpha into the numerator part, then it will become x2 to the power plus alpha. So we can write x1 alpha minus to the power alpha minus 1 into x2 to the power 1 minus alpha into this x2 to the power minus alpha. If it goes to the numerator part, it will become x2 plus alpha to the power plus alpha. And in the denominator part we have 1 minus alpha and the remaining x1 to the power alpha. So what we have obtained here, that if this x2 and x2 base are equal, so powers will be added as per the law of indices. So we will have the now we will have previously we have this. So now we will have minus alpha into x1 to the power alpha minus 1 So TRS will be minus alpha to the power, let us see it again, minus alpha to the power x1 alpha minus 1 x1 alpha minus 1. Then we have obtained x2 1 minus alpha plus alpha, because when base are equal, powers should be added in the case of multiplication. So 1 minus alpha plus alpha, that means alpha and alpha will be cut. So we will write it here, x2 1 minus alpha plus alpha. And what will be the in the case of denominator? We will have 1 minus alpha into x1 to the power alpha. So we will have 1 minus alpha into x1 to the power alpha. So now this 2 has been cut. Now we have only minus alpha into x1 alpha minus 1 into x2 divided by 1 minus alpha into x1 alpha. Now we have to take this x1 to the power alpha minus 1 in the denominator part. So if we take this x1 to the power alpha minus 1 in the denominator part, then the signs will be changed. We have to give a minus to the power. So it will now become TRS is equal to minus alpha into x2 minus alpha into x2, and the denominator part, in the denominator part we have 1 minus alpha into x1, that was from the 1 minus alpha into x1 alpha, and we are taking this part of the equation, that is x1 to the power alpha minus 1 in the denominator part. We are sending it into the denominator part. So now it will become x1 minus alpha plus 1, because we are taking the minus as it is coming to the denominator, it will take the form of minus in the power. Now it is now becoming x1 minus alpha plus 1. So in this case again the bases are equal, so we have to derive the product, then we have to add the powers. So it will become x1 to the power alpha minus alpha plus 1. So alpha will be cut, we will get minus alpha by 1 minus alpha into x2 by x1, because x1 has the power of 1 only now, so into x2 by x1. So this is basically, let me write it again, x2 by x1. So this is basically the Cobb-Douglas TRS, the technical data substitution for a Cobb-Douglas function. That means the function should be in the form of x1 to the power alpha into x2 to the power 1 minus alpha. This was the function that we have done. This was the function that we are doing, the Cobb-Douglas function. This is basically the Cobb-Douglas function, and we are doing the technical data substitution, and we are finding the technical data substitution of this function. And what is the answer of the technical data substitution? So the technical data substitution of this function is basically minus alpha by 1 minus alpha into x2 by x1.